All right, hello everybody. Welcome back to the stream. I'm Jin-chan, and we're doing some Haskell again today. And yeah, let's look at what we have on our plate. So this week we're focusing on trying to get the NBody simulation that uses the Accelerate library in Haskell to build and run, which has been a long adventure. We started young and fresh on Windows, and then went on to NixOS, and we are still a little bit like getting used to the whole NixOS thing, and made a lot of progress, learned a lot, but we're still bumping into some kind of build inconsistency that we've been troubleshooting. But I'm already digging in. Let's just I haven't done my little stream intro spiel in a while, so I'll do it. Why do I stream? Well, because I like to work on some stuff that I'm interested in the open, and also learn in the open, because I enjoyed watching other people do the same, and I've learned quite a lot by seeing developers that I like think about their work on stream. So I'm thinking, it could be useful to someone else. Plus, it gives me a nice structure to move forward with some of the things that I'm interested in. And yeah, just as a warning, I do like to follow tangents, because if this is about learning, then sometimes I need to explore some stuff that I don't understand in order to know more. And so I will definitely follow tangents, but the advantage of having some structure here on stream is that I pop back the stack. I come back to to where I came from. So so it should still be possible to follow and find something. If you find something of interest in the stuff that I'm streaming, then you should have some of that. And yeah, it's still, since I'm fairly new with all this, things might change without notice. So it's just something that might happen. In fact, things have changed without notice just last week, when I decided, hey, instead of streaming one different topic every 3 days of the week where I stream, how about I stream 3 days consequently on the same topic? My thought was, this will probably help me dig a little bit deeper into each of these things. So that's what we're doing, and this week we're focusing on this NBody simulation in Haskell. And this is a kind of a cover to think about performance in Haskell, and understand some of the existing framework to do high performance computing, so that I can suck on this knowledge a little bit and become better at thinking about performance in Haskell, which is a hard thing, admittedly. All right, so that being said, where were we last time? Just a couple of days ago. Well, what did we do? We bumped into an issue, this one right there, a compilation issue of the Accelerate library itself. And so we're trying to build the Accelerate examples, but the Accelerate examples build was failing because the Accelerate library build was failing itself. And so I actually checked out the Accelerate library itself, tried to build it, witnessed the same error, and then try a few things. And we get into a state which is a little bit strange. So let me try and reproduce that state for you. I shall get a terminal window and go into the NBody and into the Accelerate library itself. And I believe what we have is that if we cabal build this without Nix develop, then it actually builds, which is very strange. We use NixOS, so no, actually, does it? Yeah, no, it does build. So it should work out. It won't fail at the 20th or so step 21st on the data.array.accelerate type. It will. What happened there? That did not complete the build. Interesting. Huh. Not what I was expecting here. We can capable build the accelerate library outside of Nix develop, but inside it fails. Yeah, it looks to me like actually. Okay, what do you do here? Yeah, here. It looks to me like like this doesn't work anymore. Oh, that's a little bit strange. Oh, right. We should get back clean because we might be just reusing this new style folder from that we ran previously with Nix develop. So let's see whether there was a problem or not. And yeah, from inside Nix develop, it doesn't work, and I can't spot anything obvious. At least we did try a few things. We tried to see whether it was maybe the difference between Haskell.nix Cabal project or stack project. That didn't bring benefits. Both stack and Cabal fail on the same step inside Nix develop. We try to follow a different Nix packages version, thinking since my outside environment, I think, is pinned to Nix packages to 2009, but Nix develop was following unstable. Our flake was following unstable, but that also didn't solve it. Yeah, check this out. It is going further. So I think that build will complete. And so that's the stuff we tried, apart from just flailing, you know. And but there is a potential culprit that we need maybe to narrow down, and that will help us maybe understand a little bit more about Haskell.nix, which is some stuff in the docs. Okay, maybe I should backtrack just a second. I think the error comes from template Haskell because this .type module here uses template Haskell, and then it's quite suspect that in fact, even though the template Haskell module is like its order number in the number of libraries or modules is 40, the error reports the th.extra module from the same library just after that error, which doesn't unfortunately include a location and seems to be directly related to the GHC compiler itself. So that's a bit of a bummer, but that means that I'm thinking it might be related to template Haskell. In fact, no, actually, now that I think a little bit more about it, I realized that I confirmed that it is indeed related to template Haskell, because I tried to compile, commenting out this splice there, and it did compile. So indeed, we know that this is the error. And the thing with Haskell.nix is that it seems to be built with a particular focus on being able to execute, to cross-compile. Because IOHK is building this blockchain-related stuff, and some of the client needs to compile on Linux, Windows, and macOS, and so they have a cross-compilation machinery that's supposed to be well attuned to the need of doing cross-compilation, including the specific needs related to template Haskell, which is, if I understand correctly, after reading some of the docs a while back, was that the problem that can happen is that if you cross-compile for a certain target architecture, there's a risk that in fact your template Haskell code will run in your host architecture rather than your guest architecture that you're cross-compiling for. And so I think they put some specific attention to avoiding that problem. But to me, that makes template Haskell a potential culprit also because when I searched for template Haskell in the IOHK repo, there were a number of issues. And some of them seem to be talking about the fact that some stuff seems maybe broken around template Haskell. Let's see, I think page 1 had some stuff that was slightly more relevant. Can't build packages. I mean, maybe it's a bit of a jump to say that because there's issues that respond to template Haskell that actually makes it a culprit. But it's that cross-compilation story, the fact that it might mean also they're using, I think one of the machinery that they're using is this thing called iServe or remote iServe, which seems to be part of the way that they're able to do the host guest cross compilation thing. Let's see whether they no, there's no result for iServe unfortunately in here. Yeah, and then template Haskell there, and save breaking the interface of template Haskell. So that maybe is a kind of maybe a more credible candidate. Yeah, that's right, it is. It doesn't seem to refer directly to our example because it seems to be just breaking singletons, which, by the way, I'm not sure what they mean in this context. Int and unique. But basically, apparently, there's Haskell.nix patches singleton specifically. So apparently, there's some module patches. So that's, I suppose that's another potential culprit, right? It's like slight variations between the cabal. So let's add to our list of potential culprits here before we start digging in a little bit more. Another one would be a patched package somehow in the patched cabal package, I suppose we should say. So this, yeah, that's definitely a possibility, right? Because when we checked out, we did a diff of what the build logs, and some of the stuff that appeared as a difference, and yeah, you're not going to be. I need to show you this screen and move this aside. Yeah, some of the stuff that there's some basic libraries that seems to be pulled in different ways inside and outside Nix develop. Inside because and that's the inside actually. Yeah, Nix build here is the Nix develop build, because Nix develop seems to be providing okay, how to say this? Well, it builds a bunch of Haskell package dependencies as the dependency that we're compiling as Nix dependency. So basically, it injects those Nix packages inside the is it the Cabal package database or the GHC package database, such that when Cabal looks for them, it's like, oh, okay, I have it. And in fact, it's been built by Nix. Whereas outside of Nix develop, it checks the Cabal database, unmodified one, unpatched one, not Nix built, and it just fetched fetched them and then builds them. So so that's one of, I suppose that's what has the most, let's say, potential surface for trouble, right? Since if we look at the log, there's a lot of time that's being spent in fact, on, for instance, here, on the for Cabal to, in some sense, deal with those deal with those components, those dependencies, in the non-Nix way, and that's, I suppose, is one of the major differences between those two ways. So I don't know. So it could also be. So it could be that it's a patch, like maybe Haskell.nix patches things, and maybe Cabal just gets the basic stuff, or the original stuff. So it could be patch, or it could be just that Cabal is somehow plays a role in how and when template Haskell is going to be run, and that it matters that those packages are configured manually, because one of the packages in question is template Haskell itself. And I didn't say that because I just remembered that. Yeah. So that's a potential, it's the same version, but if they patch template Haskell, they patch singleton, we don't know if they patch template Haskell. So maybe that's, maybe I should write this down as another culprit, right? So patch Cabal package. So let's check template Haskell, right? See if it's patched. And the other is just that Cabal somehow plays a role in how and template Haskell will be run. And so in that case, maybe the fact that Cabal doesn't have all of the dependencies there somehow confuses the template Haskell build. So, and this is, for instance, yeah, that's one of the manifestations of this difference, is that the stated or analyzed component graph for Accelerate 133 doesn't include a lot of those low-level dependency here that I think mostly come, in fact, that's something I didn't say yet. I think that those are the ones that mostly come with Haskell and Haskell tooling. Let's go check my flake.nix. I don't have it here. Yeah, I think I have it open somewhere. But in some of the issues, right, there we go. They're non-restylable packages. That was something that I at some point added right here, and I'm going to re-add it now, just so that I can have it here, at least comment it out. So I believe a lot of these, template Haskell, term info, byte string, but not all. For instance, you see that Kryptonite's not in that list, whereas it is in the list I was showing just earlier, right there. So you have oh, and now I just noticed that actually template Haskell is the same on the two builds. Huh. Interesting. But NC terminal, base orphan, those are like, oh, at least base. Hold on, NC terminal. It's not there. Okay, so I'm definitely. But Haskell line was there. Okay, like it needs to process the diff each time we switch back and forth, unfortunately. Haskell line is not there. Or maybe it's slower. Oh, and that's component and that's unit tests. So yeah, I need to focus on this. So no, Haskell line is not there. So maybe that's has nothing to do with anything. I mean, that's something we tried. We did try to have those non-restylable packages listed, which I think means that instead of having Nix rebuild these tools by itself, we use the ones provided by GHC itself, because it seems like GHC actually ships with all that stuff. So it's a level below, I suppose. Term info, was that in there? But it's not those one that are diffed in the two things. No, term info is not there. It's a different thing. Interesting. So I wonder exactly what is the status of these ones, the ones that are not included in the Linux develop build, compared to these ones. Are there ones that are picked up by the build system, by the Haskell.nix build system, and somehow patched? So let's go and follow the rabbit hole down to this patching stuff. Patches singletons to fix this. So let's see where that happens. And so there's a patches folder, and we use GC what? Oh, okay, that's an old thing. And still only old stuff in that patches folder. We use GC 8.10.4, so that doesn't apply to us. Strange. And how many patches do we have? Only a few. So maybe we can infer that those aren't patched anymore, or has this moved? Let's check out overlay patches. Quite a bit of patches, in fact. Ooh. Really a lot of patches. None for 8.10.4 that I can see. Let's double check that we use 8.10.4. Both outside and inside. Yeah. We use the same versions inside and outside. But there's really tons of stuff that's patched. The fact that GHC is patched too is a bit scary. Yeah, this is all a bit scary. It's something that I didn't quite realize. And Cabal is patch 2, but version 4300. Huh. And then these are the things that don't seem very related to template Haskell, but it doesn't explain this, right? Like, doesn't explain why some of these would be built by the flake.nix and others wouldn't. Ah, right. So maybe those are in fact the ones that are indeed specified somehow as system dependencies when nixdevelop reads the Cabal file and reads all this. Ah, yeah. Hold on. Okay, I need to split and check out. Check this out, and what do we have? Let's go back to that part of the world. Anti-terminal base orphan. So it's definitely not all of them. And we don't have a cabal.project file here. So I don't get why those will be different. So let's run a search for, let's say, hedgehog inside the Haskell.nix folder and see if something comes up. Okay, not good. Hedgehog. Boom. It really decreases my trust in the Haskell.next way of doing things, I gotta say. So I'm wondering whether we should backpedal somehow. Also what that would look like, because the advantage of Haskell.next is that it had a well-defined story for flakes. And then the difficulty with but maybe we don't care about that problem. The difficulty with doing it the more Nix, like in a row manner, is that all of the Haskell packages are pinned to stackage version, and but that might not be a problem for us. So can we backpedal and go back to a, like, find out what is actually an alternative, a credible alternative for Haskell with flakes. So Haskell.next, the one that's coming out first. Okay, is this, that's the flake for the blog, but Haskell. Update to my serial how this blog is built using Haskell index. Oh, okay, so it's the blog, but it does use Haskell. So how does it work? Utils, generator with third party, default app, third party, blog. Packages.core package, blog.next. Okay, so there's a blog.next somewhere, and then it inherits some stuff. So where's the blog.next? Blog.next. Oh, really? You're not gonna say what's in the blog.next? That's not. That's not great. How this blog pages is generated. Building a reproducible blog with Next. So is there a blog next here? No, and this is the page not found. Suppose there is a default.next. Yeah, I suppose this is more of the traditional way to do things, I think. That's my Haskell packages, so. But generator with third party we've seen earlier. Maybe my Haskell packages.core cabal to Nix site generator is a great tool to quickly make Haskell programs available through Nix. So I suppose this is maybe the very simple version of how to do the equivalent to that of what Haskell.next is doing. So, and I think the Haskell.next folks redevelop Cabal to Nix and Stack to Nix, but there were some original ones. So let's check out where the documentation is about this. There's actually a blog post from September 22. That's good. Say Cabal init and then run Cabal to init blah to get it buildable. But it turns out you don't have to run Cabal to Nix by hand. I like that. Without writing a file. Yeah, and we want that actually, I think. So except in our case, we want that in our flake. So let's see if we can find some instructions for this in flakes. Or do we consider that those are instructions for this in flakes and that we just do what would we do? Default app apps.compile apps.compile equals flakeutil lib make app blah with derivation block ci compile. So in there, there's a CI compile. Let's see if we can find something simpler, because this seems to be maybe slightly... Aha. Oh yes, I like this. This is very simple. I like this a lot. So, okay, let's try it. So bye-bye Haskell.next, but let's be nice and let's keep it around in this fashion for now, and let's get this around, and the flake utils, we want them, and very good. And then the output, let's see, yeah, let's just comment this out, and let's just kind of start with a fresh one. Not ready to completely erase our history yet. And then what, talk about Unix with what? That's going to be what the name of the, let's see, where is it going to be? Lowercase, the project name. Okay, so just accelerate, I suppose. And oh yeah, and you can add packages for the dev shell. Wonderful. And so zlib, sure, why not? And Cabal install, nice to have. Okay, well, let's try this. How about that? Next develop. Next packages. In theory, it should be faster too. Removes a bunch of stuff from the log file. Makes total sense. Updates Nix packages to from Nix unstable to another version. That's what I would surmise that. Look at those, hedgehog, tasty. So maybe those are just cache hits in the NixOS cache, and that's why we get them. Hey, that's something I hadn't thought about. Nice. So whereas when we do Cabal builds, like if we go back to our comparison here. Not the right one, that's the right one. It would make sense. All the one on the right are actually built by Cabal. Although with a specific commit, so I don't know how standard that is. Maybe Nix plays some role in adding that hash there, but in this case, I would then think this is a cache hit as opposed to here, where it's, well, to be honest, maybe it's a cache hit too. Maybe this is a Nix package is cache hit, and this is a IOHK cache hit. Aha. I like this theory. I'm going to write it down. Patch Cabal package. Okay, let's just write it here. This is a good title, reverting from Haskell.next to call cabal to Nix. I call this reverting because I suppose Haskell.next is supposed to be an improvement on this tooling. And maybe this is the IOHK cache package. And oh, we got into an we got into an develop. I was looking at this and I was like, did it build? But no, we haven't built yet. I don't think. And then the other version, oh, it's not in the log, it's here in this version. Whoopsie. Blah. No, not this. Okay, fine. What did I do? Oh, it's the word wrapping. It's like, wait, why? What's happening? This still completely confused with my keyboard shortcuts. But hey, it's okay. Is the Nix packages cached package? I think that's probably right. Okay, so what do we do now? We cabal build, and it's very likely that it will work. We should have cabal clean, shouldn't we have? That's so then the question though is what does this cabal to Nix accelerate do with a library? Just gets the system stuff, but won't actually build the package? I'm not sure. Also, now we're going to want to do the same thing in our examples, because I get the feeling this is going to work. Except that in our example, we're going to need to make sure that we get the we get all of the overlays. So how do we? Here, there's no overlays, right? No. So we need to do let overlays blah. Oh boy, I still don't know how to handle that stuff. Okay, let overlays blah. Good, and then packages, then import also overlaying. So let's check this out. So, oh, hold on. PKGs and PKG is not the same thing at all. Do we even need PKGs? Here, apparently, it's needed for flake to get somehow the flake out of the Haskell.next stuff. Whereas here, we call cabal.next and we get PKG, and then packages is inherit PKG. I'm not sure. I'm not sure it tells me immediately what I need to do here. HS is the Haskell packages. Cabal install from HS. Zloop from Nix packages. With packages here. Ah, there we go. With packages. Right. That's it. So here they're called Nix packages. Yes. And then PKGs is created from it, and right there. So that's where we need to do our stuff. But instead of, oh, hold on, and packages means something completely different. Yeah, because accelerate example project. No, I suppose we add it as an overlay, so it's available. But you use the shell for thing. Here we do pkg override. Super. So we override the attributes here. Damn, I wish. Okay, let's try and add overlay in here and see whether, oh, not overlay, and see whether something comes up. Yes, it does. Next library, okay. Which we do while we wait for Nixflex to be widely useful. Okay, I see. So that person hasn't moved to Flex. So not that. How to overlay like all Mulu? Okay, that sounds good to me. What do we have? Google, okay, about that next. That's not the flake way. Package and package overrides, yes. Check, holy moly, this is a very detailed post. Wow. Nice. Very nice. Okay, that sounds like something I definitely want to keep around, and so let's keep it around. The log. Yeah. But let's take a look at Flex here. Oh yes, I forgot about. I forgot about this. Unfortunately, Flakes are not part of the picture at this point. That's too bad. But we'll still use this sometime. Must include call Latinx, yes, must include Flake as well. And then Latinx. Okay, let's see what the person has done. PR. Doesn't seem like we find what we need here. Flex and def shell. Yes, I like this. Output equal blah overlay. Hold on. Cabal to Nix. Oh. Nix tree. What is this? Concise example using Flix with the Haskell project. Okay, well, not as concise as the one we were just checking out, but this one does have overlays though. And so Nixtree is the name of the package. It's doing a bunch of stuff, but this is added as an overlay. And then def shell, the shell for from Haskell package. Okay, let's check out what we have. See, that's very strange to me that this doesn't, like the def shell doesn't even have shell for. I'm quite surprised by that. So many different ways of doing the same thing with Nix. Okay, so that's one thing. Is there a Cabal to Nix later on? There isn't. So that's the only example that that uses Cabal to Nix. So we could get the overlay. The Nix tree then is said to be. Nix tree is not in the overlay. Or is it? Yeah, no, it is. And it's self.haskell.lib, just static executables. Oh, I see. And self Haskell packages Nix tree, which I suppose is this override. So it sort of puts itself into the Haskell packages. Interesting. Okay, and then it's in inherit overlay. And then with the flake utils and each default system. Which we used to do in a completely different way, right? We had a flake util leave each system actually wrapping the overlay definition. And the overlays and the packages were just defined in a block in the overlays equal. Okay, so I think maybe I can adapt this. So surely we don't need most of this. We don't need the Haskell.nix overlay, that's for sure. We don't need this, but we'll need probably need something to replace this override there that we needed. I'm not sure how we're going to pull that off. Weren't we building something? We were, and it did complete. So that's all good. Yeah, we now need to move back to trying to build it with to build the examples. But then being able to patch a dependent package is going to be important. So let's hope. Is this here somewhere here? Might not be. But it could be that it's in that discourse thing. Hold on, did I already move out? I kept all the I always keep all the tabs, and I didn't keep the one that I said was important. What? Okay. Pinning these packages, now we were doing. Break down what's going on. That's fine, we don't need to. Adding packages and package overrides. Yeah, I think that's kind of what we want, right? My Haskell packages. Black compile override. Yeah, that's the version. All override self-lib compose extensions. SFL super GHC blah with packages. Wow, this is then GHC with packages. GHC with packages, and then overridden package here. Rec equal blah with a different with an overridden package. So it's possible to override packages. it's just a bit it's just a bit ceremonial, boilerplatey. But or you can also use call hackage. It does not need a SHA-256, but rec was not in the ORCABAL hashes, so need to use call hackage direct. I see. Okay. All right. So there is a way to override specific versions, which I thought was something that Haskell.next introduced, but it's not exactly right. It's probably just that Haskell.next makes it easier, but it's actually possible. It's just ugly. Or but I suppose you should be able to do this in a cleaner manner, no? Don't check just static executables. So we had some of that. Don't check. Put in extra different packages that you have to build them yourself. Haskell build times are reasonable, but often the tests are slow. Okay, don't check. Well, make sure that it's not that it doesn't test. And you're putting a tool, not a library. Let's say you want the latest version of VCID because it has allo eval. Then you do the just static executable thing, which is what that example we're looking at does for Nix3 for some reason, which is strange because I thought that this was actually building Nix3. So why would you pull yourself into the package somehow? So somehow Nix3 itself is included in a dev shell. This sounds very non-standard. It sounds very strange to me. But here we see interesting. I was actually looking for something like this for our PureScript stream. Yeah, that's interesting. Allows to use flakes to refer to the GitHub folder and then just sort of import them from EasyPS and then put them in the dev shell. Shell 4. Yeah, I'm interested in shell 4 because this doesn't use shell 4, but this example did, right? The Nix3 example did use shell 4. What is this here? This is for non-Haskell stuff. Yeah. Okay, yeah, let's take a look at shell 4, but that is, well, return a derivation whose environment contains a GC, the only dependencies of packages listed in packages, not the packages themselves. Oh, in which case then it might make sense to have Nix3 in the list of packages, because you wouldn't have Nix3 itself. Okay, interesting. Using Xshell in this derivation will give you an environment suitable for developing the listed packages with an incremental tool like Kabbalah install. In addition to the packages arg and with Google args, anything that can be passed into std and make MQ derivation can be included in the input str set. So shell 4 and then like build inputs. Aha. I suppose this could be a way that we smuggle in last resort, but that we smuggle in the NVIDIA X11 or NVIDIA X11 Vulkan beta system dependency in the Nix develop shell. It's not right, but it should work for us. So do we want to, I think we want to rewrite this. We don't want this kind of dev shell. We want the shell 4, I think. So let's pick that up. And then packages, I think this is a trick to get Cabal to Nix to write down all the dependency tree, and then here make sure that you get all but the head or the leaf of the dependency tree. So let's try this. This shall be accelerate examples, and right, that's the reason that it's overriding Haskell packages, is because this should be in Nix packages. This is strange. So this is taking P and returning P dot accelerate examples. Interesting. Ooh, we do have that syntax here actually. Oh, it seems like that's the syntax. That's it. Huh. Okay. And so what happens if we don't do just static executables? Yeah, that I don't get, why we do just static executable for. Ah, not the haddock. This doesn't work. You can take a more direct approach and call Cabal to Nix on the source itself, for example. Oh, I see. Ooh, funky. Add to the native building post. Okay, is that that I think is the override pattern we're looking at right here, and that's what Haskell.Nix automates all of these pretty sophisticated things, but we can do them manually. Okay, so that's pretty cool, I think. Get the missing library for GHCID. That's the one right there. So extra equal, and then add the missing library to the Cabal. What did I do? Double clicked on the thing. Oh, I must have clicked on share. And then extra then gets added through what? Inherit extra right there. Yeah, wow. This is definitely very involved, but at the same time, it means we have control over it and don't depend on the rest that Haskell.Nix does. What's that? That's in shell 4. Show how to create an overlay with your custom Haskell package set Tweak that package set to have what you need. Use the custom set to create a derivation for your project and add some build tools hooks. There's a shortcut you can take, a function called shell for. Lets you create a shell based on the custom package set and lets you add extra tools option. You can use this to keep creating the overlay and DRV tools I create. For now, I'll leave this tutorial as is, since overlays are used throughout Nix packages, not just Haskell. While the shell for concept is only set up for some languages. It's just the same thing. And then some of the other smart folks are adding out more details on it. That's pretty awesome. And this is a pretty long thread, in fact. Well, not super long, but current tooling works well if all your dependency can be compiled with a version of packages specified on package. Right. Some of them don't. Can go horribly wrong. But horribly wrong, I don't know. Why do you say horribly wrong when this seems to have some recipes for it? But I should update it for 2021. It's not that anything about wouldn't work, but that there are easier and more concise ways of doing Haskell development in Nix in practice. Okay, Skyfall, I want to see your work on GitHub, please, because I want to see those new and more concise ways. This is you. Hello, Martin. Okay. What do we have here? HS Nix template, Haskell project template can be built with Nix and developed by GC. I didn't get on install. Oh, what? He's working on GIGTK declarative? We were doing that last week. Holy moly. It's amazing. What? What? Okay, is that... No, it's behind. I didn't even realize that these guys have a whole proper Nix environments and so on. Hold on one second. Is that when updated April 26? So maybe this HS Nix template is actually something good to look at. And then usually that stuff would have, well, it doesn't have the flake. Default.nix.shell. So it's unfortunately it's not shell based. It's not flakes based, I mean, but maybe some of these patterns are reusable. Yeah, I suppose none of this was flakes based. In fact, it's just that we need to sort of do the merger in our head. Can we do that? Yes, yes we can. Okay. Can we try? Yes, we can try. Okay. So I think we need to go that route because it looks like the much more, even though it's not as terse as where we started with, which makes me a bit sad. I'm not sure we can pull it off with the super simple thing, like this packagey thing. We have the PKG, so in that case the PKG is not in the Haskell packages namespace, so it's not obvious to add it to a shell, which is probably why this dev shell, hold on, yeah, this dev shell indeed used a different approach, used the env override. And I fear that this is not going to give us as much flexibility, but I might be wrong with that. It seems like potentially valid alternatives. Yeah, the fact that this shell 4 is mentioned there, but not particularly expanded upon, is a bit sad. But I suppose here there is the shell 4. This, so let's look at it just a tiny bit more. That's the exe, there's the shell. And so we can probably just make def shell equal. And instead of packages.haskell packages, here we have my Haskell packages, because my Haskell packages is actually overridden. Ah, right, okay. So I think that's the slightly more concise version of what we were looking at before. I think if we say something like let's see, how are we going to do that? Let's just copy that over. My Haskell packages. And yeah, so this shall be accelerate examples, same as this. And oh, git ignore function, I didn't know about that one. And then unfortunately, then this, does this add overlays? Not that I can see, right? So, well, we don't know exactly what the overlay thing is going to be, but what we know is that we can use this my packages here, and that this should give us oh yeah, we need to do that, but yeah, we need to include that package thing, the P thingy here, like we do. So perfect, accelerate examples. So here we pull all the dependencies, but we don't build accelerate examples itself. And then we can have build inputs if we want. Ah, okay, no, that's good, that's good. So build inputs will be additional tooling, because we have here whole bunch of stuff. So that's all good, and that would be just packages, Haskell packages. So that's the same principle. And so here I believe we could also add a Haskell language server. And then Nix packages format. Don't know that we care so much about that. We don't have Google, which is probably also fine. And then I think it means we can get rid of all this, but we haven't solved the overlay issue. And there's or the package override issue yet. So the overlay issue, okay, the reason why we had this overlay issue is because we needed Haskell.nix resolution to hit this overlay. Do we need that with this setup? I wonder. It's not completely obvious. So I suppose we could try without the overlays and see what it gives. And then this HS thing, I think we're not going to need. And so this will keep around because we probably are going to need it later. And that's it. Finally, we can try something. So let's exit here and let's go into the accelerate examples, and then let's Nix develop and see what's up. Compiler, yes, indeed. It's going to be for us. How did you get compiler from? Ah, okay. You just do this. Okay, that's fine. We can do that. Except for us, it's 10.4. And then we launch the thing, and it doesn't work because git ignore is not here. Okay, git ignore, what's up? Where are you coming from? Oh, right, okay. Git ignore source pure. Yeah, I'm not sure whether we want that, but let's add it. I suppose it has evolved as a pattern. So, and then pkg. Yeah, we don't have a default package anymore, and that's all good. And then we inherit pkg. That's also probably something we don't do anymore. I think we just have a def shell as an output. Oh, but no, we're in Flakes. We shouldn't do that. We should actually say that we want, I don't know, my Haskell packages. No, what do we want? Yeah, we need to adapt this. Okay, how did it work before? We said that in the Flake, the default package was flake.package, but the Flake came out of the Haskell.next malarkey. So it's not clear how we refer to the package itself. Maybe, oh, hold on. No, I think I know. I think it's my Haskell packages dot accelerate example without actually needing this. And in fact, I'm realizing that we don't need this in most cases. I mean, for us, we don't need this. So, oh, this might be a string though, but I'm not even sure actually whether it needs to be a string, but I think this is probably fine. Is it fine? Undefined variable pkg. Yeah, that's right. So the other thing is, do we have packages? And I think we cannot have that. Is that correct? Must be an attribute set. Well, it is an attribute set. What are you talking about? In blah. Oh. Are you unhappy with this? And we need to specify it manually, which is fine as well. Can do that. GC 10.4. That was not the problem. Ooh, 8.10.4. But so output in. Oh, sorry. Got it. There was all this extra stuff in there. Do we want to get back to a compiler thing? We probably want to get back to a compiler thing. Must be an attribute set. I'm modifying the right file. I am. Okay, fine. Let's get rid of this. And oh, yeah. No, hold on. Let blah outputs in what's the problem? Do I need to add the flake.next? Not the problem. Okay, yes, please show trace. Okay, so there must be just a syntax error then. What's this? This is a system thing, and then this is this thing. Okay, so maybe it doesn't work with because I suppose this is a function, so maybe it doesn't work with flakes because we need to in fact have a JC 8.10.4 listed here and not have a function. Yeah. And all right. Okay, let's not have a show trace and see what's up. Hello broken. Haskell package next is marked as broken. That's not nice. Unstable. Stated. Oh, it's our package is marked as broken. Oh, okay, allow and free. Yeah, we do need to allow and free. How did we do this before? We okay, let me pick up the effect.next here and allow. Oh, here pkgs, and then right, we just overlaid, and so it still should be fairly easy to overlay, in fact. Right, okay, I still don't know how to copy paste properly. Okay, copy, paste, and still don't know. And I suppose for now we actually don't have overlays, but inheriting system seems fine to me. Okay, let's see where that takes us. But that's good. It means that in fact we have somewhere to fit in the overlays. But that's a dependency. So it looks like we're going to have to allow broken for some reason. Does this mean that it doesn't compile? It probably does mean that, and it means that maybe we'll be able to contribute something, maybe, if we fix it. So let's see if adding config broken will work. I will need to do it like that. Yes, it proceeds further forward. Very good. Totally deserves drinking a bit of water. I see NVIDIA things. How come we get NVIDIA things? We actually didn't specify NVIDIA things, so it means that the cabal. How does it? Why does it fetch NVIDIA things? Is it building the whole world right there? glib, LTK plus 460, 6 gigabytes. Well, it's going pretty fast. I think my download issues with the cache have significantly improved. NVIDIA EX11, how? And OpenGL, how does it know? We didn't have to override it or to include it manually. Is there something in Nix packages that does this? How? Or is it the cabal.nix, the cabal2nix function? By the way, this is going to be too recent of a driver, I think, for us. Oh no, could I took it 10.2. That's also correct. We didn't have to specify anything. So it deals with system dependencies better than the whole Haskell.nic stuff. I am very surprised. But how does it even infer it? I suppose the thing I'm thinking about is that in Nix packages, some of the accelerate dependencies somehow have been annotated with the system dependencies, and so even though they're broken, they might have some stuff that allows it to work in there. And indeed, accelerate is somewhere. Math. Okay, that might be another. Okay, we bumped into an error, but hold on. We need the Haskell. Not here. Here. Haskell things. Haskell module to Nix. This package depends on software with an non-free license. That's a YAML file. Configuration for package to Nix. Okay, but it has the crazy module list, a package list. So is that what builds Haskell packages somehow? On the must be, right? And so what about? Yeah, those are listed as broken packages. So that's the list. And but I don't see accelerate in there. Or maybe it's a transitive thing. Okay, let's see what didn't work. Test didn't work. Okay, well, it's just been disabled. Say to reinstall the package with -fnofib to enable it. And then it has a error for another test suite. So I suppose we should do the don't check thing. Nofib LLVM native. That must be, yeah, accelerated LLVM native. It's here, so that's the part of the broken bit. Okay, all the world is consistent. So let's get the don't check thing and carry on. How do we do that? Yeah, it's not simple. Is there a don't check example in some of the stuff we were looking at? Definitely not here. Somewhat realistic flake. I don't know that we care about that. Don't check here. No, don't check here. Don't check here. That's mostly where we saw it. Here? No. I think it was in one of the template project stuff that we were seeing this, wasn't it? In the default.nix here, wasn't there a don't check here? There wasn't. Okay, let's try and wrap our head around this. With my packages, Haskell packages, blah. Native build input, all native build input plus plus. that overrides the native build inputs of drv.env. Aha, yes, the .env thing is what happened here. Okay. So it's what happened here, but okay, I need to recuperate some context here because I deleted some of the stuff that corresponded to that pattern. It wasn't this. Damn, I lost myself. We can get rid of the Haskell.mix stuff because we're trying something else. And yeah, I think it's one of the things I closed earlier right there. Library, history, recently closed tabs, and that would have been one of these, or was it really? It's not this one. This, yeah, that's where I thought it was. That's the pattern. Here, yeah, mix tree. No, it is not. Okay, it was in GitHub, and we checked out Flake and call Cabal Tunix. I'm pretty sure that's the one. And so PKG here was, yeah, that's what I thought. It was PKG's right, it was this itself. I mean, it was the core Cabal Tunix blah, which is now in accelerate examples, meaning I can access it by, I think, my Haskell packages dot accelerate dot example dot env. Pretty sure. Meaning that if I want to override the inputs, then well, it makes me think that we kind of want to have something called PKG. That's kind of, it feels like kind of convenient. And then we can say equal PKG, and we can say PKG equals. That sounds kind of slightly more reusable and maybe even legible. And to be honest, we don't have to make this multi-line. And then that means we could do inherit package PKG here, and that would be the default thing that gets built. And in fact, yeah, in fact, this is also PKG. So default package is just PKG. And then in this case, def shell just was overriding some stuff. For our case, if we want to fix this, we want to override our import of accelerate. So that sounds like that's actually just an overlay, right? we want to replace accelerated LVM native by just static executable calling core package blah, I think. Or the don't check version of, and then core package direct. That's fine actually. I think we could do this. So if we said and then maybe we can actually I'm not sure, but maybe we can actually add this as overlays rather than this with this ATTR, this override ATTRs. And let's double check that again it's not a pattern that's being used in this. Yeah, no, there's no overlays here. Okay, so instead of rec, this would be accelerate LVM native, and we will be I suppose self is fine. Maybe, don't know actually. Let's see, I need to look at the whole example here. What is self? Did that self or not? It's PKGs, so let's just use PKGs. There we go, don't check, and then here that would be okay, H self. So I think this is what was called HS, if I'm not mistaken, in this example. It's just packages.haskell packages, right? Pretty sure, and I kind of like that as well. I think that's kind of neat and tidy and terse. So let's try that, and let's try hs.callPackage direct, and then what we call LVM native, and oh, apparently we could avoid having to provide the SHA by doing some smart thing. I get the source, don't check. Go package direct. Okay, call package. I hate this search tool. This is really completely backwards. I really hate it. Okay, I think if we go to the search through here, it will work. Yes, it does. Okay, call package. A trick to get the SHA-256 is to put 52.0. You can also use call package, which does not need a SHA, but rec was not in the OK. Yeah, that's right. So we can do call package instead. And we do need to provide a version, and maybe we can find this. Where can we find this? Oh well, it's 1.3.0, I'm pretty sure. So let's do that 1.3.0. So at this point we replace, well, we're doing something that really should be in an overlay here. So so let's do that. Let's do that. I think we know how to add an overlay now. I think we do this. We say hello, this is the overlay. We add a mine to see whether we need to reactivate this later. And right here we add overlays. So let's rearrange those in a way that makes sense. And then I think this is not bad at all. But and then do we even need to do this? I think no. I think we replace this by. Oh no. We absolutely need that. I mean, we might actually be able to do better, but this is the part that makes my Haskell packages available. We just changed this PKG thing, but yeah, there might be a way to even continue iterating on this and making it better. But what do we have? So overlay is popper. And this also closes nicely. And this goes here. Oh yeah, of course. Semicolon. There we go. And HS. What's up? H-self. Yeah, that's right. That doesn't exist. So go about to next. Yeah, we need to go back to what's up in this guy. Go about to next. Oh yeah, that was in H-self, but that's from PKGs, so it's just PKGs again. Curiously, I would have thought that maybe it would have been HS. Let's see whether that's HS. Yeah, exactly, right? That's what I would have thought. That it would be in HS. Indeed. And is there another way where I think we could maybe... No, HS call package, that sounds good. Yeah, no, it's this is actually HS right there. So with HS. And my Haskell packages, I don't like this. I hope, pretty sure we can replace this also by an overlay. Let's try this next. Could attend 2. Sounds good to me. Wow, I'm surprised it just built CUDA 10.2 without a problem. Hold on. We didn't succeed. We're bumping into the exact same error. So, but hold on. No, this is... Which one is it? So let's accelerate test no fib. So let's accelerate test no fib. So hold on. Okay, I suppose if it's using the cabal file, then it's true that we don't even point to in the cabal file to the locally checked out accelerate library. For a while we tried to maybe do this here in stack, but here we're not using stack anymore. But we did build out a, if it used the cabal.project file, which is not sure that it does this, by the way, then it would have built our locally checked out CUDA, which maybe it did, not sure. But here is it's yeah, it's not failing inside anything accelerate example. It's failing in accelerate. But for some reason, it looked like it was accelerate native there. But, hold on. And here, same. So maybe what we need to don't check is the accelerate, in fact, even though it seemed that that wasn't part of the broken things, but maybe maybe it should have been. Okay, so let's try and see whether we can do that. It should be exactly the same as what we did here, except with accelerate. And I'm still not copy pasting properly. So let's just do that and then that. It seems to be rebuilding CUDA. I'm not sure about the reason why it's rebuilding here. It's a bit strange. Could it be because somehow it's part of the Nix shell? Some of that stuff. But inheriting the PKG here, well, if I suppose if I did Nix build, that would be maybe a different story. I suppose. Yeah, I'm not sure how this works. But we probably want to launch Nix develop with a -L next time so that we can see the more detailed log. And we bumped into the same exact error. Let's see if we learn more through this. It looks like it's going to rebuild the whole stuff again. Okay, so overlaying didn't work. We do have the overlay. We use it here. Aha. do we need to call like about to next stuff from the overlay? That would kind of make sense, wouldn't it? Meaning well, actually that's already the case because we import pkgs with the overlays and then we do HS, so the order was actually correct. So maybe, oh, but hold on, it's not a package pkgs overlay, it's more, it's deeper than that. It is a packages GHC10 for override. So okay, let's put them inside here instead. Kind of makes more sense, doesn't it? Okay, let's try it. But let's wait to see this is finished. It's annoying that it rebuilds. Why would it rebuild? Okay, let's do it again. We have a new flake. And it looks like maybe, yeah, in this case we have the identity overlay, so it's fine, it won't matter. And hopefully this is the correct way to override the Haskell packages, right, instead of an overlay. I mean, I think it's possible to do this in an overlay, but it's just a bit more cumbersome. Sorry, that'll be a native 33 out of 35, 35 out of 35. Wait, run the test now. Has more to build. exe equal here, I suppose is similar to our default package. It's not a flake, but when you inherit exe, I wonder. Oh, I see. Okay, CUDA finishes our building tests. Damn, it doesn't work. Build inputs, pkg Haskell packages. Okay, let's look at the override code again. For example, derivation with tool, it uses the .env yeah, I suppose we're not doing that at all here. Here, extra gets the done check, and then it gets added as its dependency to core-cabat.next. Oh, hold on. Here, you inherit these guys. Inherit, accelerate LLVM native. That wraps it on check, and then it's passed as an argument to cabal2next. I think maybe this needs to be like so. Although probably not. Yeah, no, not. So something else is a problem. Disrupt the DRV function to add an override scope function to the result. And this DRV thing is wrong. Make package set. Called with unexpected argument, accelerated LVM native. Aha, was there something? Yeah, you had to fetch the thing from source. So GHC ID SRC is like some upstream package fetched from source. And you do have an overlay here. Oh, but that's, I think, is another use case. But here, I think your main derivation for the name of the project was empty. But then you did drv.env.override ATTRs. So I think, yeah, that's what I'm missing here. Okay. We can't do this. We need to, once we've done that thing, even yeah, that's right. Even here, we need to do okay, hold on. What am I doing here? What am I missing? I'm missing a oh yeah, I'm missing some equal sign somewhere here. But apparently some other stuff. Okay, yeah, for some reason something disappeared there. Okay. So DRV here is, I think, my Haskell packages. It's not actually. Oh, hold on. No, it's package. It's package. But this is what? Is this really? Supposed to be DRV with tools, but so it's kind of, it's a it stands in for DRV, so it stands in for package. So that's kind of like the final package in some sense to its package. Let's call it prime. And then we say that's default package. Oh, right. And hold on. Ah, yeah, maybe my Haskell packages. Yeah, are overridden with accelerate example in order to have it here. But really, we want it prime. So I think that's right. Okay, let's try. And I forgot to. Oh yeah, right. Okay. So first of all, I need to remove this. Well, actually, if I should copy it because I want to, in fact, use it here. Such that I do replace these things, but oh, holy moly! Yeah, I think this is not the exact same pattern, and so it's hard to. Oh, right. Hold on. Yes. Don't check here, but I suppose maybe just don't check accelerate and don't check. Oh no, we don't need the don't check here. We can just put them like this, I think. Okay, like so. And get kebab depth missing. Okay, we're getting further and further into a rabbit hole. My Haskell packages, accelerate example tries to take this new version, which, oh, there's an issue with that, right? There's a not mutually recursive thing. Okay, is there any comment about this particular aspect here? It's possible to disable test hydrox profiling for all derivations at once. Huh. Oh. Interesting. Possible to deactivate everything, but then we don't have... Then nothing will come from the cache. Maybe we can live with that. Do you prefer to disable tests on a per dependency basis? Yes. And then there's this template here. That's the same we've been looking at. It is, right? Oh no, this one's updated. But maybe we want the updated one, but can we spot a difference? Not immediately. But it doesn't have all of the things we're trying to do, like a particular overriding a dependency so that it doesn't check. Here there's only the just static executable for the top level thing. Yeah, that's new right there. And yeah, no shell is dot shell. Yeah. So we've seen that. And anything else? Let's get packages. Since this guy fault suggested. To Haskell next project structure. Okay. Very similar as to oh, okay. Oh, I like that. So we want the don't check. You have don't check, you do. That looks like an overlay, right? Yes. Yeah, so that's the pattern of overriding Haskell packages in an overlay, I think. Which is fine. But yeah, it's modular, but therefore maybe it makes it just a tiny bit harder to read. And so if we did that in an overlay, then and what will we gain? It's not clear. Maybe clearer because it comes from packages, but then there'll be this weird thing of the package that we want to build itself being defined in an overlay. But maybe that's fine. Let's let's roll back to where we were. Yeah, when we try to make those overlays, not when we try to make those overrides. Yeah, when there were overlays in there. So then this looked like this pattern, except for the fact that we need to do this. And then close our stuff. Boom, and boom, and that's it. And then right, we need the GC version, and you know what? I didn't even think of doing it the proper way with just GC version in a string up there in the let clause. overlay has packages. Okay, no, HS packages. So HS packages. It's not an overlay. At least if we do it like so. I think maybe we can make it an overlay. Maybe if we say that this is that final dot Haskell packages equals final dot self dot Haskell dot packages. Is that right? Oh, feels very complicated. No. Hold on. Okay, this guy's not closed properly. So we need another this. Okay, balance the system. Yeah, that makes sense. Okay. Oh boy. Yeah, I'm definitely getting at the end of my rope here. So definitely don't know whether this is actually going to work. And here we have our packages, and so in theory HS here, because it's has the overlay, is going to be this overridden version, and so therefore, and the packages is going to be the overridden version, therefore we can do this trick here to do the call cabal.next, and it should still work in theory. Yes, and this is so super then in this case is oh, look at this, Haskell equal. So I'm wondering whether I made another no, you know what, I think that's right. I think that's right, and then super is meant to be self. Actually, prev in an overlay. Well, to be honest, I wasn't even expecting that. Okay, it works. I didn't completely screw this up. Didn't we have something like this in our other project? where we're going down one level in the dependencies to try and check. Well, let's see if this works. And yeah, if it doesn't, I think I'll just sign off here. We can try and fix that next time. So let's see. So we get away from our problem by switching away from Haskell.nix to call cabal to nix, and we're still on that journey. But now we need to skip tests for accelerate LLVM native. And we shall know whether this works or not in a second now. That's our blocker currently. So I'm going to capture the error message if it shows up again. And this way we know that's where we stand. And yeah, it's doing the test. So we have not solved our problem yet. All right, so there we go. That's the error. And we shall solve it next time. Thank you so much for watching, and I will see you soon. Bye-bye.